Today we'll be focusing on how to take the derivative. Just the first step, so we are not going to simplify the expressions afterward. And you guys can download this file. We have a total of 30 questions, including the power rule, product rule, quotient rule, chain rule, and the derivative trig functions, inverse trig functions, log derivatives, implicit differentiations, all that. And you can also download a derivative table. Well, you have to know the derivative, so it's like a blank one. You have to make sure that you remember all that first before you do this. First, we have the derivative of e to the square root of x. Look at this as e to a box. And the derivative of e to the box is just e to the box. So it's going to be e to the same thing. And then here we use the chain rule. We multiply by the derivative of inside of the box. The derivative of square root of x is 1 over 2 square root of x. And this is it. This is all I want to go over with you guys. Alright? The first step when we are taking the derivative. Of course, you can put this on the top, and some of them you can simplify it, but we are not really going to focus that. Maybe in a future video. Now for the next one, derivative of secant of x squared plus x. Here we have an inner function here. Derivative of secant of a box is what? Secant box, tangent box. So we will have secant, the box inside, use parentheses for the answer. So x squared plus x times tangent of that. Now, what's the derivative of inside of the box? Well, it has two terms. The first one gives us 2x, and the next one gives us plus 1. And that's it. This is the derivative for that. Now, for number 3, we have a quotient, yeah? So here we go. I'm going to square the denominator right away before I forget. And then we will put the bottom function to the top, parentheses, all right, for these two terms, 1 plus cosine x. And we multiply by the derivative of the top function. Derivative of sine is cosine. And then we minus the top function, which is sine. And then we multiply by the derivative of the bottom function. Derivative of 1 is 0. Derivative of cosine x is negative sine x. And again, I'm just going to leave it like this. Make sure you know the very first step of doing the derivative. Now for this one, we have the derivative of x squared times tangent x. We will need to use the product rule. I'm going to keep the first function, and then we multiply by the derivative of the second. And the derivative tangent x is what? Secant square x. Okay, multiply by secant square x. And then we add the second function times the derivative of the first. And that will give us 2x. And that's it. Now for number 5, we have 1 over 2x plus 4 to the 4th power. You don't need to use the quotient rule because we only have a 1 on the top. So we can bring this up and make it into a negative exponent. So we look at the derivative of 2x plus 3 raised to the negative 4th. So we can see we have a box raised to a negative 4th power. Therefore, we can just use the power rule first. So we get negative 4 times the box raised to the negative 5th power. And then what's the derivative of the box? Well, we get 2. So that's it. Now, for number 6, notice that we have the square root of x over x squared plus 1. So here we have the inner function right here, right? That's the box. So firstly, take the derivative of square root of a box. We get 1 over 2 square root of the box, which is that x over x squared plus 1. Then the derivative of the box, we need to use the quotient rule, right? Because it's a quotient. So I'm going to square the bottom. So we have x squared plus 1 and then squared. And then I'm going to put down the bottom function here, x squared plus 1. And we are going to multiply by the derivative of the top. Derivative of x is just 1. And then we subtract the top function times the derivative of the bottom. Derivative of x squared plus 1 is just 2x. So you need to multiply by 2x. So remember, we have to square the bottom here and then do the quotient rule, and that's it. Number 7. Okay, straightforward quotient rule, because this time we have square root of x over the bottom here is not inside of the square root. So this and that are different. Straightforward quotient rule. I'm going to square the bottom and then put the bottom function here, x squared plus 1. And then we multiply by the derivative of the top, which is 1 over 2 square root of x, minus the top function times the derivative of the bottom. Derivative of x squared plus 1 is 2x. Now for this one, notice we have e to the ax times sine of bx. So we will have to use the product rule as a big picture. And then this part, it's like a small box, like was that, it's also a small box. So you have to use the chain rule along the way as well. So I'm going to keep the first function for the product rule, and we multiply by the derivative of the second. Derivative of sine gives us cosine, and inside here, this is like a box here, it stays. So put down the bx. But what's the derivative of bx? B is a constant times x, so it's just going to be b. And then we have to add the second function, which is that. Just keep it as how it is. And then we multiply by the derivative of the first. Now, this is e to the something, right? E to the box. The derivative of e to the box is e to the box. And then multiply by the derivative of the box, which is going to be a. So that will give us the derivative for this. This is a very common Calc 1 exam questions, right? All right, for number 9, x squared times e to the negative 3x. Product rule. I'm going to keep the first function times the derivative of the second, and this is e to a box. So we first have that, e to the negative 3x, and then we multiply by the derivative of negative 3x, which is just a negative 3. And then we are going to add the second function, which is e to the negative 3x, and we multiply by the derivative of the first, and that will give us 2x. So that's the answer for that. All right, number 10, we need the quotient rule. So let's go. Let's go ahead and square the denominator. So 1 plus e to the 2x, and then square. And I'll put the bottom function here, 1 plus e to the 2x, and then we multiply by the derivative of the top, which is 2x, minus the top function times the derivative of the bottom. And the derivative of 1 is 0, derivative e to the 2x. So here it's e to a box. So we will first get e to the 2x, and then multiply by the derivative of 2x, which is a 2. So here you have. Number 11. Notice here we have tangent to the third power written like this. So this means we have to differentiate tangent of 2x inside of a parentheses first, and then raise to the third power on the very outside. So the first step is that we have a box like this, raised to the third power. So the outer picture here, do the power rule first. So we have 3 tangent of 2x, and then raised to the second power. Now look inside, take the derivative of tangent of 2x. The derivative of tangent of a box, right? 2x is a box like this. The derivative tangent is secant square. And then you keep the inside. And finally, you multiply by the derivative of 2x, which is a 2. So we use the chain rule twice right here. Now, number 12 is perhaps the funnest one on this worksheet. So first, you have a square root of this thing, so square root of a box. So right away, I'm just going to write it as 1 over 2 square root of this thing right here, x plus square root of x, and then plus 1 more square root of x. Now, I'm going to multiply, but it has this and that, so 2 terms. Make sure we have a parentheses. Derivative of x is 1, and then we add the derivative of this thing. Derivative of square root of this box, right? Because this is square root of a box. the derivative of this square root gives us 1 over 2 square root of whatever the box is you put inside. But we will have to use the chain rule. Now, do not close the parentheses right here, because the chain rule is for the derivative of this part. So I'm going to just multiply by the derivative of this. And again, it has x plus square root of x. It has two terms. Parentheses. The derivative of x is 1. The derivative of square root of x is 1 over 2 square root of x. This together is for this part right here, the square root of x or plus square root of x. And then the 1 is right here. And that will do it. So for this one, the chain rule is only for this. It's not for the very outer part. So be careful with it. This right here is it. Yeah. You can see that these two are going to be quite long. So that's why I can only fit in 2 questions right here. But anyways, though, we look at this one, right? Number 13, we have this times that. So we will need to use the product rule, all right? I'm going to first keep the first function here. So we have 7x plus 1 to the third power, and then I'm going to do the derivative right here. So we have a box, yeah, this inner part raised to the fifth power. So first we have to bring the power to the front, so multiply the 5 here, and then minus 1 to the power, and the inside stays the same, and that will be to the fourth power. And what's the derivative of the blue box? Well, remember it has 3 terms. So open the parentheses. This right here will give us 2x. This right here will give us plus 4. Yeah, like that. And that'll do it. And then continue plus the second function, which is the red part here. Just write that down as how it is. And then we multiply by the derivative of the first. Again, here we will have a box raised to the third power. Bring the power to the front and then minus 1. So 3, 7x plus 1 raised to the second. And then the derivative of 7x plus 1 is 7. So multiply by 7. So yeah, that's it. Let's try another one similar to that. Here is the first function. Just keep it. Now multiply by the derivative of the second. Again, we have a box raised to the second power. So put a 2 to the front, minus 1. So times 2 times x squared plus 3x minus 5 to the first power. And then the derivative of x squared is 2x, and then plus 3x is going to give us 3. Minus 5 doesn't matter. It has 2 terms, so make sure you use the parentheses. 2x plus 3. Yeah. And then we are going to add the second function, x squared plus 3x minus 5 squared times the derivative of the first. Here, x squared plus 1, box to the third power, yeah? Put the 3 to the front, the box inside stays, and then that's subtract 1, so you get the second power. And then the derivative of x squared plus 1 is 2x, so multiply by 2x. Yeah, just like that. Alright, now we have these two equations that we will have to use implicit differentiation because the y is not isolated. So let me put down ddx to mean that we are going to differentiate this with respect to x. And x is just going to be the independent variable, so y is a function of x. So be careful here. If we take the derivative of x to the fourth power, that's just regular 4x to the third power. But here we have a product. So I'm going to keep the first function, and then we multiply by the derivative of the second. Put the 2 to the front, and then minus 1. So we have 2y. But because y is a function of x, so this is more like a box to a second power. Therefore, we multiply by the derivative of y with respect to x, and that's how we get the dy dx. And then the other part of the product rule, here's the second function, and we multiply by the derivative of the first, which is 2x. Yeah? And then next, here we have y to the third power. Again, this is like we have a box raised to the third power. So bring the 3 to the front, and then minus 1 to the power. And here we multiply by the derivative of the box. So we need the dy dx, just like that. And then the derivative of a number, right, that's constant, is just going to be 0. So this right here will do it. All right, the next one. Again, why it's not isolated, you can just go ahead and do it like this. And I think let's just do it like that. Even though you can multiply this right here, but in that case, you have to use the product rule. So anyways, though, I'm just going to do it based on its look. So on the left-hand side, we will need to use the quotient rule. So here, I'm going to square the denominator. And then I'm going to put the denominator here, the bottom function. And we multiply by the derivative of the top, which will give us 2x. And then subtract the top function times the derivative of the bottom. Now it has two terms. Make sure you open the parentheses. Yeah, so we have the derivative of x is 1 plus the derivative of y. That is going to be the dy dx. Okay, so it's like that. And then on the right hand side, the derivative of y squared, this is what? Like a box to the second power. Put a 2 to the front, y, and then minus 1 to the power. And then here, don't forget to have the dy dx as well. And then you will have to solve for dy dx from both sides like that. Okay. Number 17, here we need the implicit differentiation. So let's go ahead and put d dx. Here we have e to a box. Yeah. So we get e to the box first. And then we multiply by the derivative of the box. The derivative of x over y, we will need to use the quotient rule. So here we go. I'm going to square the bottom. And then we have the bottom function here. Multiply with the derivative of the top. Derivative of x is just equal to 1. And then we are going to subtract the top function, which is x, times the derivative of the bottom. Derivative of y with respect to x, which is the dy dx. All right, and then that is equal to derivative of x is 1, derivative of minus y is minus, and here we get the dy dx again. Yeah, so that will do it. See, if you just focus on doing the derivatives, it's not so bad. It's pretty enjoyable. The harder part is how to simplify this, and sometimes it gets really long, right? So that's why we are just focusing on the derivative. Now, for number 18, again, implicit differentiation because the y is not isolated. Derivative of sine x is cosine x. Derivative of 3 times cosine, that will be a negative, right? And then the 3 stays. Cosine, the derivative is negative sine. Yeah, negative sine for the cosine. And then the input is y. And we have to remember, this is like cosine of a box because y is a function of x. Here we need to multiply by dy dx, like that. Okay. And then the right hand side, the derivative of 5x is the 5. The derivative of 7y is just 7. And then this thing here gives us the dy dx. Just like that. All right, back to just regular differentiation. Number 19, x times ln x minus x. For the first part, we need the product rule. Let me keep the first function, multiply by the derivative of the second. And what's the derivative of ln x? If you say 1 over x, you are correct. 1 over x. And then we add the second function times the derivative of the first, which will give us 1. Well, don't forget about this. The derivative of minus x is minus 1. So that's it. And in fact, they cancel out to be 1. 1 minus 1 is 0. And finally, this right here gives you the answer, just ln x. Now for number 20, we will need the quotient rule. So I'm going to square the bottom. And then I'm going to have the bottom right here, ln x, times the derivative of the top. Derivative of x is 1. Minus the top function times the derivative of the bottom, which will give us 1 over x. Now, for the next one, we have ln of this thing inside. So we have ln of a box like this, yeah? Derivative of ln of a box is just 1 over the box. So let's write that down first. 1 over that. Then it has two terms, so open the parentheses. Derivative of secant x is secant x times tangent x. And then we add the derivative of tangent x, which is secant square x. And that'll do it. It's just a chain rule. Okay, for number 22, ln of a box, like this. So we will first have 1 over whatever the box is, which is that. And then two terms, so let's open the parentheses. Derivative of x is 1, and then we add derivative of square root of a box, yeah? So the derivative of square root of box is 1 over 2 square root of whatever the box is. Now, this is similar to one of the questions that we did earlier, the square root of x plus the square root of x, that one. Here, we will have to multiply by the derivative of the box, which is 2x, right next to this part only. So do not close the parentheses right here. This 2x is only multiplied with this part. After that, we close the parentheses. Again, if you just focus on square root of x squared minus 1, this has the derivative right here, okay? And that will do it. All right, number 23. Have a look. We have the y here and also the y here. So we need to use implicit differentiation because the y is not isolated. Here we go. Put on d dx. The derivative of y with respect to x, that is the dy dx. Now we have ln of something, so ln of a box. It's going to be 1 over the box. And then we multiply by the derivative of the inside. X squared will give us 2x. And we add the derivative of y squared. And that it's really the same as saying this to the second power. So 2y and then dy dx. And the dy dx is only for the 2y. So it's just going to be like this. Now, for number 24, even though we just have a y on the left-hand side, but here's the trouble. We have a function for the base, and the power is also a function, it's an x. So we cannot just use the regular power rule or the exponential rule. But this is what we can do. Whenever we have a function to a function power, let's take the natural log to both sides. Because this way, we can use the log property, bring the power to the front. But do not minus 1, because this is just the logarithm property. So this equation becomes ln y equals x times ln of 1 plus sine x. Now, even though the y is no longer isolated, but we don't have to worry because we can use implicit differentiation. And the beauty is that we don't have a power we don't have a function to a function power like that anymore. So implicit differentiation now. So here we have ln y, so it's a ln of a box. We will get 1 over y times the derivative of y with respect to x. Now on the right hand side, it's x times ln of this. So product rule. Put on the first function times the derivative of the second. Derivative of ln of this right here, it's like a box. We will get 1 over that box. And then we multiply by the derivative of the box. Derivative of 1 is 0. Derivative of sine gives a cosine x. Okay, continue. The second part, we add the second function, ln of 1 plus sine x, times the derivative of the first, which is going to be 1, and then we are done. Now, for number 25, we have the same issue like the one we had earlier. We have a function for the base, likewise for the power. So let's go ahead and take natural log both sides. That way we can put the power to the front. So we have ln y equals this ln x times this ln x. So in fact, we have ln x to the second power. So let's use the parentheses, ln x raised to the second power. Now, be super careful with this notation. This notation means that we have ln x times ln x, which is different than ln of x squared, because this means you have ln of x times x. When the power is inside, you can bring the power to the front, yeah? But this right here, you cannot do so. The power cannot go to the front. These are two very different situations. So now, implicit differentiation, d dx. Okay, ln y, so it's a ln of a box. We have 1 over y times dy dx. Now on the right hand side, here we have ln x to the second power, so it's a box to the second power. Put a 2 to the front, minus 1, so 2 ln x to the first power. And then we multiply by the derivative of the inside, which is 1 over x. So that's the answer. Alright, number 26, inverse sine function. So here we have this right here for the box. And remember, when we have inverse sine function, the derivative is 1 over square root of 1 minus the box square. So let me put down parentheses first. So it's a box square. And the box is x squared, so let's put that down right here. Now, multiply by the derivative of the box, which is just a 2x. So it's just like that. Number 27, x times inverse sine x plus square root of 1 minus x squared. Here, we will need a product rule. So keep the first function times the derivative of the second. That will give us 1 over square root of 1 minus x squared. And if you look at the inside, the derivative x is just 1, so you don't, if you use the chain rule, it's multiplied by 1. If you forget the chain rule, it's fine, you know. And then we continue. We add the second function times the derivative of the first, which is going to be 1. Now, for this right here, we just have to add the derivative of square root of something. So square root of a box is 1 over 2 square root of that. And then multiply by the derivative of the inside. Derivative 1 is 0. Derivative of negative x squared gives us negative 2x. And this right here will do it. If you simplify it, you end up with just inverse sine x. Now, number 28. Notice that we have inverse tangent on the inside and then raised to the second power. So here we have this as our box. Put a 2 to the front, minus 1. So we have 2 inverse tangent of x to the first power, and then we multiply by the derivative of inverse tangent of x. I kind of forgot. I got it. It should be 1 over 1 plus x squared. Done. Alright, last two questions. For this one, we have inverse tangent of x over 1 plus x squared. So we will need to use the quotient rule. Let's go ahead and square the bottom right away. And then we'll put the bottom right here, so 1 plus x squared. Two terms, make sure you use the parentheses. And then we multiply by the derivative of the top, and that will give us 1 over 1 plus x squared. And then we subtract the top function times the derivative of the bottom, and that will give us 2x, just like that. And now, for the last one, we have inverse tangent of this thing, so inverse tangent of a box. So first we have 1 over 1 plus the box squared, and I'm going to put down parentheses squared. This right here goes inside, so square root of e to the x minus 1. Then take the derivative of the box. Here, square root of something inside. So square root gives us 1 over 2 square roots of the box. And just write this down inside. And lastly, we take the derivative of e to the x minus 1, which is just e to the x. So it's just like that. So hopefully after these 30 questions, you are more confident, more comfortable, and feel better about taking the derivative.